So we get a nice way to start the second semester. This is our last video for the chapter. It's the last section of the chapter, and it's dilations. So it's an enlargement or a reduction. So just like we've talked about before, we've talked about scale factor, and that's what we're dealing with here. We're dealing with making it grow or shrink based on a certain scale factor. These dilations with the center at the origin, the dilation comes from here and expands out. So it's going this way and this way, vertical and horizontal. So we have our K factor, our scale factor, which is K. So our new X values are going to be K times X, the original. New, original, which I guess is the same as what we've been doing all along with the other parts. Now Y prime is K times Y, because the center of the origin, we're expanding both ways. Now, consider triangle ABC with vertices 1, 1, 4, 1, 1, 4 under dilation with center at the origin and scale factor as follows. So I'll do A in blue. So we get the point, this A is 1, 1, right here. And then B is 4, 1. I know you guys are getting pro with graphing. And then we have 1, 4 right there. So that makes triangle ABC. A, B, C. Now what we do, that's the original. Now we're going to do part A. So we're going to double those values. So now A, I'll call it A prime, is now going to be 2, 2. 2 times X, 2 times Y. B prime is going to be 8, 2. C prime, 2, 8. So my new coordinates are going to be 2, 2, 2, 8, way up here, that's C prime. This is A prime, and then 8, 2, right here, B prime. So when K is greater than 0, K is greater than 1, it's an enlargement. Okay? K is less than 1, greater than 0. Oh my goodness. Can't think of the word. I am looking for a reduction. So, that being said, you look at the next one. We have K is 1/2. Get rid of that. Put it in red so you know what's going on. So now my coordinates for part B, all these values are divided in half. So I have 0.5, 0.5, because many of you prefer decimal. And this one becomes 2, 0.5, and this one becomes 0.5 and 2. And that's C prime, B prime. I'll do those in a different color again so we can see what's going on. So for B, green, 0.5, 0.5 is probably right about there. 2 and 0.5 about there. And 0.5 and 2 right about there. B prime, A prime. And for some reason I have to talk lighter because I made it smaller. Anyway, so there's A prime, B prime, C prime based on a dilation of 1/2. So all my values shrunk in and we're based on the center. So everything lines up here and lines up here. So we're expanding out in both directions. And I had 2 graphs, but I put them on one. Next. So find the equation of the image when y equals x squared is dilated with center 0 and scale factor 3. So that means y prime is going to be 3y, x prime is going to be 3x. But we want to replace x and y, so we get these. So that means y is going to equal y prime over 3, and x is going to equal y prime, x prime over 3. So I replace in the equation, it now becomes y prime over 3. Replace y with y prime over 3. Replace x with x prime over 3. So y prime over 3 is equal to x squared over 9. I got to get rid of that 3. So I'm going to multiply both sides by 3. And that leaves me with x squared over 3. Or, if you prefer, 1/3 x squared. Now, we haven't really graphed a lot of parabolas yet. We're going to be getting into that. I'll give you a quick rundown of what y equals x squared would look like. We're going to start at -3, -2, -1, 0, 1, 2, 3. So I can pick the x values, and then I square them to get my y values. So -2 squared is positive 4, -1 is 1, 0, 1, 4, 9. So I plot those points, 0, 0, 1, 1, -1, 1, 2 and 4, -2 and 4, 3 and 9, -3, 9. Connect the dots. And that's y equals x squared. Now what I'm going to do to graph this, to show what this is going to look like, I'm going to take all my x squareds and divide them by 3. So divide by 3 gives me 3. 4 over 3. 1/3. 0. 1/3. 4/3. 3. Not going to look pretty here, I gotta say. So we still have 0, 0. And then we get 1/3. So when x is 1, we have 1/3. And there, -1/3. 2 is 4/3, so that's going to be right about there. And there. 3 is 3. And -3. 3. So that scale factor of 3 is kind of messed up with what it ends up doing to our graph. And the expectation here was that it was going to enlarge it. And I guess technically, if I continue on, it is making it wider, but it's not the same, doesn't have the same effect as it does with the triangles. Now, so that's when we have a dilation for x and y. The next thing we're going to talk about is going to be a vertical dilation. And a vertical dilation only impacts y. And same idea, we have a k for a scale factor, but it's only changing our y values. And often that's what we're going to run into, is most of our graphing involves a vertical dilation, but not a horizontal dilation. Now, consider the triangle ABC, under a dilation scale factor. So in this case, we're dealing with a vertical dilation. So that means x prime is still going to be x. Now y prime is going to be ky. So that little rearrangement means y equals y prime over k. I feel like I made a mistake somewhere. I want to go back in video here. No, we're good. Now, so my x values aren't going to change. So I have my original 1, 1, A, 5, 1, B, and C, 1, 4. I like how they're making these nice and easy for me to see. K equals 2, so 1, 1 is going to become 1, a y prime. I want y prime. I don't even need that. Y prime is going to be 2. This is for A. B to B prime is going to be 5 and 2. And C to C prime, I'm just multiplying everything by 2. It's going to become 1, 8. Now, because this is only a vertical, we're only dealing with the y value. So my new one, I have 1, 2, 1, 2, which is 8 prime. I have 5, 2, and 1, 8. So it's moved it up and changed how it looks a bit because we're doubling. Now we'll go over to this one. I'm going to move, that doesn't matter. We'll go over here. We're going to plot our original 1, 1, 5, 1, and 1, 4. So now what's happening is our k value in this case is going to shrink our points. So I'm going to have 1 and 1/2 is going to be a prime in this case, and 5 and 1/2, and C 1 and 2. So we're shrinking it down, we're pushing down on it kind of thing. So we're moving it down. I've got that and that. There's A prime, B prime, and now C prime is going to be 1, 2, right here. So now my triangle does this. So I've pushed it down, plus while I was pushing it down, it kind of shoved the top to shrink it down a bit. I'm going to stop on this video so you can take a break, and then we'll come back. We're going to talk about horizontal dilations.